Good morning, everybody, and welcome to our webinar on de-risking offshore wind through predictive simulation with focus on ports and developers. We've got about just under 50 attendees at the minute, and we're expecting that number to go up quite a bit. So it's really good to see you all have joined. We're expecting quite a range of participants, mixed from developers, port owners, port authorities, some government and trade bodies, as well as a number of consultants as well. And some of our competition, I think, are joining as well, but perhaps trying to learn something from us. But you're all welcome. Thank you for taking the time to join. And yeah, I hope we have a good session. Next slide, Anchor. So the session will last about an hour. And yeah, we appreciate the time you've given for this. I realise you're all very busy. The agenda, we'll do a bit of an introduction to Haskoning, only a short little piece just on who we are, and I'll set the scene a little bit about some of the challenges in the renewables and offshore wind sector. We'll then talk a bit about predictive simulation, the power of it and what it means. We've got a case study coming up from ASCO with Haskoning and Scottish Enterprise, so a project we delivered last year. And then we'll have a future look around the capabilities of simulation in industry and what it can do. And then we'll then close with a Q&A session. We'll probably have 5 to 10 minutes of questions and answers. And if you've got any questions, please put them through the Q&A section in the Teams Town Hall event, and we'll pick those up at the end and run a session to respond to those. If we run out of time, we will respond directly to you, so we will get an answer back to you. And the session will be recorded as well, and we will share this through Haskoning's channels at a later time. So our presenters this morning. So firstly, myself, Stuart White. I'm Director of Offshore Wind Ports for Haskoning, based in the UK in our Brighton office. I'm a civil engineer by background, but have been involved in shipyard and renewables projects for over 30 years now. We've got Praveen Lawrence, he's Director of Energy and Logistics Solutions, based in London, again, the UK. Steve Jones, he's our leading professional for simulation, also in the UK. And we've got Titian Lagundang from ASCO. She's Head of New Energy and Net Zero Infrastructure. Next slide. So I'll do a little piece about Haskoning. Next one again, if you can. We're an independent international consultancy. We've been around since 1881, so it's a really long history, and we combine our kind of traditional engineering and design capabilities involved in design and consultancy projects, but we bring in software and technology over the top of that and solve a number of our clients' challenges using the combination of those. And what we will present today is a very good example of that. We're just under 7,000 staff numbers, so a medium-sized consultancy, and you can see the map footprint of where our offices are around the world. So we're running at about 65 offices, and we are number 2 in revenues as a business for port and marine facility design and consultancy work. So we've got a fairly major player in that sector. As a business, we have a company promise or an ethos is around enhancing society together. We take that promise very seriously, so we're very selective about the projects we work in, and we do our utmost to leave a positive impression on society with our work. So we focus on the UN sustainability goals and have a matrix here to measure the impact we are having to make sure it's as positive as it can be. Okay, next slide. So a little bit on the business. So we're very heavily involved in offshore wind around the UK. So we've consented around 18 gigawatts. So that's environmental permitting. So we've been involved in the industry for some 25 years. Globally, we've been involved with around 40 gigawatts of wind in some capacity, supporting a range of developers and investors. So we've got a very good understanding of the global industry, and our marine and kind of port design team is around 650 staff. So a big group. On the right, in recent years, we've made some quite important acquisitions that really help what we're doing at the moment. First one is Arch Henderson. So in Scotland, they run for about 5 different offices around Scottish Waters. So it's given us a much greater understanding of that particular market. Secondly, Pondera. So they were acquired just over a year ago. And they are a Dutch-based renewables consultancy looking at the kind of wider value chain in both onshore and offshore wind. And finally, Portwise. So a month ago, we acquired Portwise, and they are a specialist port simulation consultancy, dealing primarily with container terminals and kind of processes of highly automated processes in ports. But we're bringing that wider capability into the simulation team for offshore wind. So it's quite a comprehensive offering as a business. Next slide. So the wind ports team, so we focus on a number of things just to give you a sense, and this does overlap quite nicely with what we're presenting today, but we do a fair bit on business consultancy, so looking at kind of market and pipeline, commercial strategy of projects, and looking at kind of revenue and financial models, trying to make business cases as positive as they can be. We do a lot of port planning, so that's just kind of facility layout, looking at logistic chains back into a port, how to forecast and get the kind of layout as best it can be. Then port design in the middle, that's the large part of our business, is the more traditional kind of design services, which got a lot of expertise in. And then we're involved in logistics and digital modeling, so how to model those logistic chains, particularly in the renewable industry, developing digital twins and the like. And finally, manufacturing assembly. So we're involved in component manufacturing facilities, also foundation assembly and design, and that again overlaps a little bit with the logistics and digital team, but there's quite a wide spread of capability. And along the bottom there, you can see some of the projects we've been involved with over the last couple of years. Okay, next slide. Just to give a bit highlight some of the things we're doing to give you a sense of the range of projects we work on. So we do a fair bit of commercial work, looking from the investor side, looking at the business characteristics or the commercial characteristics of an investment. We do quite a lot of industry and kind of national studies. So we wrote the NZEC project in North Sea, looking at port capacity for offshore wind. We wrote the floating offshore wind industrial roadmap 2-3 years ago for Renewable UK in the UK. It's quite an important study around floating wind. The next two quite traditional bit of work for us, so a kind of port selection study. So we do a fair bit of work in the Philippines at the minute. And Bristol Port, we're designing a terminal at Bristol for floating wind. We're doing some work for the World Bank at the minute in Colombia. We do a fair bit on manufacturing assembly, so a piece on a concrete manufacturer assembly in France, some shipyard work looking at floater assembly for a confidential client back 2 years ago. And finally, we do a fair bit of kind of towing and installation simulation work as well, which we'll touch on later. Okay, next slide. I'm just want to set the scene now for some of the challenges in industry and some of the things we're trying to address. And I realise a lot of the audience will probably know this, but I thought it was helpful today just to set the scene. So next slide. So there's a lot of market uncertainty at the minute. It's facing a lot of challenges. Obviously, the costs are rising, projects are being delayed or cancelled. Quite a lot of failed auctions are still very common. There's many issues around grid connection, and that uncertainty is making it very difficult to find the right investment, basically get the size right and functional requirements right for a port to make sure the investment or capex being spent is optimally selected. There's a lot of very heavy industrial processes, so often parts are difficult to handle. There's a lot of operating equipment, and it's normally on a kind of a critical path, so there's not a lot of alternatives. Facilities are very often pushed to the limit. So you'll see most ports, the land area, berth space, water depth, it literally every space of a port is filled. And very often a developer will want more, as in you want a bigger buffer zone or more space for ever increasing turbine sizes and technology requirements. And that constraint, so the port is often ending up, it is principally the enabler for offshore wind, but is also often the biggest constraint. Operations are often pushed to the limit, so we do a lot of work around kind of met ocean conditions, weather conditions, availability of ports, and then the difficulty in predicting that, and how do you then map that into an already constrained environment. And then finally, how do you actually find that sweet spot? and that's a little bit what we're doing today, or certainly doing the analytics to try and get as much data as possible to make the most informed decision as you can. Next slide. The supply chains in offshore wind are quite complicated, so they're obviously very well connected. We do quite a lot of work in looking at different kind of build strategies, and there's a looking kind of the European model or Southeast Asian model, and how that impacts a choice in terms of the way the port operates, certainly the heavy lift and transfer equipment. So we're now trying to model those to again find the ideal solution. Both fixed and floating wind have very different challenges. And the fixed bottom wind market is pretty mature, and most kind of issues have been ironed out. There's still constraints on space. And when you're looking at a floating market, where there's a very different set of challenges around assembly, wet storage, and also the distance and travel distance between a port and the site creates its own set of difficulties. The components are also very large, difficult to move and handle, often critical path. And also the market situation, again, making that very difficult. And you can see that at the minute with the current instability, it's getting difficult to predict prices. So it's more important than ever to get that sweet spot properly chosen. And that leads itself very nicely into digital simulation tools. And they can actually deal with most of these issues. So whether it's market, kind of logistics flow, or a facility layout design, they actually apply some very logical thinking and it can open a lot of possibilities relatively easily. So I will now hand over to Praveen, who will pick up a bit more on predictive simulation. Thank you.
Yep, my name is Praveen Lawrence, and I'm responsible for the energy logistics solutions that Haskoning offers. Yeah, Stuart nicely set the scene for the challenges that the offshore wind industry is facing. Whether it's a developer or a port, any player in this industry, they are looking for certainty when making major decisions. Some of the impact of these decisions that are made now will be felt, say, 5-10 years down the line. So that's why certainty is essential, or people are looking for certainty. And predictive simulations lets us test decisions before we commit real money, time, or resources. It shows how a system will perform under different scenarios. So we can identify risks early, optimize performance, and choose the option that delivers the strongest return. For large, complex, or capital-intensive operations like the offshore wind industry, or advanced manufacturing, or supply chain networks, simulation reduces the uncertainty, accelerates investment decisions, and builds confidence across the different stakeholders. In short, simulation helps leaders make better decisions faster and with far less risk in it. Businesses face tough decisions: how to control cost, introduce new processes, or adapt supply chains. The traditional approach is to use static tools like spreadsheets, but they can't capture the complexity of these challenges. However, simulation allows us to model scenarios, test the different assumptions, and minimize risks before committing to decisions. So that's why simulation makes a difference. Can you go to the next slide, please? And as an organization, we have been in developing simulation. We have simulation experts who have been spending years and years, more than 30 years, developing solutions for not just for the offshore wind industry, but also for the wider renewable industry. And we have also built significant expertise within the manufacturing. We have done a lot of work for automobile industry, oil and gas, of course, looking at the LNG industry, for example. So we have done quite a lot of things, not just limited to the renewable industry alone. Within the renewable industry by itself, we have done, as you can see in the slide there, we have done a different variety of activities there. So the models we have built, so focusing back on the offshore wind industry, we have built models for the installation and operations for the offshore wind farms, everything from vessel scheduling, port utilization, manufacturing and assembly of major components, for example, monopiles or towers, jackets, cable manufacturing. So these includes looking at factory layouts, workflows, planning, material flow optimization, and throughput forecasting. And of course, there's supply chain and logistic planning. And that's a case study that we will be looking at further today in detail. Next slide, please. Answering the business questions is difficult when the processes are complex, variable, and interconnected. And simplified analysis, as I mentioned earlier, for example, with Excel, can often lead to wrong decisions being made. Simulations gives a dynamic view of operations, turning some of these uncertainties into clarity and helping businesses make smarter and data-driven decisions. Simulation captures the variability and complexity of real-world processes. At Haskoning, we use simulation to build dynamic models that represent both current and future operations. These models help organizations understand performance, predict outcomes, and optimize resources. And offshore wind industry is a classic example of that system where there is complexity, variability, and interconnectedness. So you have all the different components there, all with significant risk of knock-on effects, weather uncertainties, and schedules which potentially can, with so many interconnectedness there, they can potentially fail. The goal is to ask critical what-if questions, explore cause and effect, and turn further future performance accurately. By simulating changes before implementation, we reduce risk, optimize investment, and improve stakeholder confidence in the decision making. We go to the next slide, please. Haskoning, we use our own simulation technology. It's called Witness. Witness has been around for more than 30 years. It's a predictive simulation software which enables you to understand your business through dynamic models, which can be used to test and validate decision making, as well as understand your business processes. By using Witness, we can model your processes, test them against multiple scenarios, and get to an optimal performance recommendation that improves your business and its future operations. Predictive simulation delivers smarter business processes, enabling organizations to streamline operations, increase efficiency, and support digital transformation. Let's go to the next slide. Okay, a few benefits of predictive simulations. Witness simulation delivers multiple benefits to make smarter, more data-driven decisions, from reducing the impact of implementation changes through to business case justification, maximizing resource effectiveness. Simulation can give you the insight into these business challenges and questions. This enables organizations to streamline operations, increase efficiency, and support digital transformation. Also want to mention about how we can support the digital transformation across the supply chain. As part of the digital transformation strategy, predictive simulations play a role at every level of facility, from planning and design to daily operations. Digital models enable organizations to adapt faster, make improvements, and stay competitive in a rapidly changing environment. Many companies now have a goal of creating a fully connected digital twin of their facilities, connecting multiple data sets into one system to enable both future decision making as well as real-time feedback to make operational decisions in a timely manner. And simulation engines like Witness actually are at the heart of these digital twins. So how do you use these? Next slide, please. So what do we offer in terms of simulation? For logistics simulation studies, we offer a range of solutions, anywhere from just offering the software to full consulting. Often what happens is we have customers requesting us to do an initial study, and at the end of the study, we offer, and they actually take this tool along with them. The tool often is provided with an easy to use Excel interface, Power BI, for example, for visualization. And that actually helps non-expert users to start using the tool continuously beyond the project, and that enables them to extract more value out of these works that we do. So that's why we have the flexibility to not just to offer a study, but also to go beyond that and offer the tool in the hands of our customers. Maybe this is a good point where I hand over to Steve. And
thanks very much, Praveen. Yeah, just to introduce myself, thanks to Stuart and Praveen. My name's Steve Jones. I'm the leading professional for simulation as a topic at Haskoning. I sit within a team of consultants with a huge amount of experience. I myself am from the operational research and mathematics sort of background. I've been doing simulation for over 20 years in a range of different industries, but with a strong focus on manufacturing and logistics. I just want to say a little bit about what we offer from our team. So we have a range of services for simulation, right from the ability to get you using our software Witness with the right training to pick that up in the right way. That can be part of a public training course or a private on-site or remote course. To get you up the capability curve to be able to use this technology to answer your own business questions. And that's with a great range of support through a portal, ability to ask questions, and following on from that with lots of mentoring and advice on best practice. That's one end of this scale. In the middle, we see a lot of our customers don't want to have to develop their own capability in-house around simulation. So we offer solutions in that space where we develop simulation-based applications, and we help people scope and roadmap what needs to be in them. We design them, we develop them, and we leave people with a tool that allows them to experiment with their business process, such that they don't need to come back to us for each next scenario, and they can do that experimentation and find the insights themselves. And on the right hand side, you can see our consultancy offering, where we do an amount of the modeling, also with a huge amount of domain expertise on our many years of experience. We turn the simulation model into actionable insight from our analysis. We hold workshops with stakeholders so they can interpret what the results mean, and we offer independent technical review and assurance of modeling. So there's a full range there. However, whichever way you want to go about simulation, we can offer those services. Next slide, please. So just in terms of how a project might look like for potentially sort of more solutions-based approach, or if we're developing a simulation ourselves, we go through these steps. And we're very keen in our practice on starting with the end in mind. So starting from the insight we want to gain and what questions we're trying to answer, working back to know what we need to be able to see to make a decision around that. Work back to what scenarios we'd need to test in order to find that insight, to what scope of model we need to have, what depth and breadth of scope needs to be included, to work back to what needs to be in the model and develop that. So that's our process that we're about to show you a little bit of a case study of one of the projects we've done around Scotland. So next slide, please. I think we've had a bit of a technical issue, and we don't have our guest speaker, TTN, along to talk about that. That's a real shame. I was just going to set a bit of the context, but I'll take you through the case study and tell you what we've been doing on this project and how you can see a bit more of it in the report that's been published. So next slide, please. So a little bit of context for people that are joining from around the world. There is a major transition in sustainable energy underway in the UK, and particularly Scotland. Scotland has a great amount of natural resources to work in the wind sector. That is bringing a huge transformation in the sector. Across that map, you can see on the right hand side there are many leasing rounds for sections of the seabed to enable new projects to be set up. Some of those are fixed bottom projects, and many of them are floating. This is obviously a an ambitious plan to do all of this, and the UK government has big ambitions by 2030 to implement quite a lot of these projects. Obviously, from the picture on the left as well, there's a serious engineering challenge behind this all, which is where Stuart and his teams come in and help ports and developers understand how they're going to meet those engineering challenges. And this is sort of the context that we got involved with ASCO and Scottish Enterprise around the problem of, if many of these projects are going to happen in parallel across the ports in the east of Scotland, how is that going to work with them sharing port space? How is that going to work with them interacting with each other? What might be the best strategies to enable that logistics chain to work? So next slide, please. So ASCO are a logistics support company. They can offer many services around logistics. They do much of that in the oil and gas industry that's there in the east of Scotland and around the world. And Scottish Enterprise, working on behalf of the Scottish Government, looking to understand what Scotland could do to meet this demand for increased offshore wind capability. So we came up with this scope of work to do a study where we start from what needs to be true at ports in Scotland, what are the requirements for fixed and for floating wind projects, to go through the ports in East Scotland and look at the suitability of those ports and whether there are any gaps, development needed, to identify and evaluate some suitable port strategies, and we'll talk about those in a bit more, what that means, and then to model that using Witness, our simulation software, for 3 of these major ScotWind projects and 1 INTOG projects. Those are either research or projects linked to oil and gas platforms, and then to disseminate those outcomes via a report. So what you're seeing at the bottom there is a little bit of the detail about what's included in the simulation. So we'll talk a little bit more about that, but the full detail is available in a report which has been published by ASCO. So next slide, please. So looking at the port functional requirements, we had our teams and Stuart's teams looking at the maritime requirements and the port requirements around navigation, channel width and depth, quayside requirements and equipment, the landside requirements in terms of laydown areas, assembly areas, and we also looked at wet storage. We made some things out of scope for these requirements. We weren't looking at substations or grid. We weren't looking at cabling. We were primarily looking at the primary components of the wind turbines, both fixed and floating. And so when we looked at a huge range of ports, 160 ports, harbours and shipyards along the Scottish coast, and screened that based on our criteria to get down to, I think it was around 12 or 13 ports that we wanted to test in our different strategies. Next slide, please. So we came up with 4 projects that are representative of the sort of projects that are going on around Scotland. So we wanted to have a mixture of these. We've got 1 INTOG, 3 ScotWind projects of varying sizes, different numbers of turbines in different locations with different start and end dates. And some of these have, the floating ones have different foundations, construction, and we've got a fixed project in there as well. And then we came up with our strategies that we wanted to test these projects against how they performed using different ports in different ways. So our first strategy is a super port to have all of these projects complete in parallel through the same period of time from 1 port. We looked at splitting the integration between different ports. We looked at spreading the different activities among the most capable ports nearest to the given project and really spreading that out across our 12 or 13 ports. And we looked at a hub strategy where we had a hub based on each foundation type or foundation construction material. So those different strategies led us to a range of different ports that could meet that strategy, and we tested around 50 different scenarios with variants of those, with variants of different ports, but also applying, as Praveen was talking about, the uncertainty of weather and more adverse weather effects, what that did to our results. Okay, next slide, please. So the model we've developed is a proof of concept. We've designed it in such a way that it is modular, such that we can, it's parameterized as much as possible, such that we can develop this further in the future and compose those different modules to use on different applications. So using Witness's modular approach, we've got modules for the entities and flowing through our simulation, so the components, the sub-assemblies, assemblies, and the finished units. We've got place modules looking at manufacturing locations, ports, and the wind farms. We've got transport modules looking at the shipping and the vessels, and also at the weather. And we've got a sort of logical driver module looking at the bill of materials and the scheduling of how these projects will work through time, what the triggers are to start manufacturing, what the decision point is to start assembling, integrating, and install. So putting all that together, we work through time in this predictive simulation from today's date out for 8 years, looking at a high level across those different activities. So, for example, manufacturing and project sites are very much black box. We're not looking at the detail in this simulation manufacturing as we do in other simulations. We're trying to understand what the logistics chain might do under different constraints. Okay, next slide, please. So here we have one of the views we have of animating the simulation. So we have on left and right 2 different scenarios being played out through time, and out at sea what we're seeing there is a progress bar on the 4 projects, 3 ScotWind and 1 INTOG, and in our ports we're seeing the laydown area fill up and empty out as those projects progress. There are many different ways to visualize what's going on in the simulation. This is just one of them. I think on the previous slide, we looked in a little bit more detail of what's happening in a given port. All of that information could be visualized. What we actually do is run these simulations. I mentioned we have 50 scenarios, and each of those scenarios we actually run multiple times. So on each of those, we're rolling the dice on things like weather. We're understanding what the best and worst case outcomes might be. And we take a huge range of data from the simulations, output that, and graph it and chart it in Power BI such that we can develop insight into that we put into the report. Okay, next slide, please. So what were the conclusions of the study? Really, we had sort of 4 main questions we were trying to answer. I said this is where we start and this is where we get to at the end of the project. So we were looking at how feasible are our 4 port logistics strategies. What we found were with the assumptions and the parameters that we put in, that all of the strategies could be feasible. What we found was our super port strategy with the level of integration berths that we put into that scenario faced some challenges in adverse weather conditions. But we found that by increasing the number of integration and commissioning berths from that number, which was based on publicly available data at the time, we were able to sort of work with that to bring that program back into alignment with expectations. So all of these strategies are capable and feasible if done in the right way, and that's interesting information for Scottish Enterprise to know who to work with and how to get collaboration to work. We also then looked at a number of sort of sub-questions. What would happen if there was a different amount of wet storage across Scotland? If it was in different locations, does that change the effectiveness of our port strategies? We also looked at the time it takes to integrate and commission and the bottleneck at the integration berths that we saw. If that could be reduced, what effect does it have on our results? So yeah, all the results are available in that report. So if you want to get into more of the depth, please feel free to find that out. Okay, next slide, please. So finally, from me, just wanted to talk about how simulation could be useful potentially for your applications and what opportunities there are for us to collaborate with yourselves in the future. So next slide. I think Stuart and Praveen have already mentioned we work across a wide range of different applications, but just looking at simulation, we do a tremendous amount of work in manufacturing, whether it be jacket assembly programs or high voltage DC cable factories or steel rolling. We work with manufacturers on those facilities to look at their throughput and their utilization and their programs of work, and see that they can avoid their risks and maximize their throughput. We also work with ports to understand things like laydown area, their berth constraints, their channel access constraints, other traffic around their port. All of those things interact, and we can help them with understanding that and predicting what might happen if they change work with different developers. We work with developers directly. Stuart mentioned a project there looking at transport and installation. Again, the scope of that is towards the sort of the back end of what we looked at with ASCO and Scottish Enterprise. It's just the transport and installation. With the ASCO project, we're looking at a much wider supply chain analysis. So that's another option. We work with governments to help them understand how best to use the national resources to get the best bang for their buck, using simulation to help with that analysis. And then simulation is also part of sort of the forefront of digital twins, and this being used in more and more in operations and maintenance to understand what the fleet of turbines and support vessels will need to do to keep that capability running. So lots of opportunities to work together on simulation. What I would say is a lot of these sort of involve collaboration between ports and developers. They involve collaboration between multiple ports, and sometimes those things can be difficult to do without sort of a grounding in an analysis of what might happen under a certain set of conditions, and simulation can give you that forward-looking view. So yeah. Okay, I shall hand back to Stuart, I think.
Thank you, Steve. Thanks, Praveen. Yeah, just firstly, apologies apologies to Titian actually for not being able to join. So she is here, but we've had a technical issue. It means she's been unable to join into our town hall event via Haskoning. So it's just a technical matter. So I think she is in the call, but only as a viewer. So apologies to Titian as well as those that hope to hear her story. We've got, I think now we're going to have just Steve, Praveen and I will respond to some of the questions. So I think we'll come onto the screen, and I will just chair this session, I think. So we've had a few interesting questions come in. I think I can probably just start from the bottom. So first question is, how can simulation help developers de-risk projects in earlier development stages? Who would like to pick that up?
I can pick that up. Yeah, I think it's really interesting. A lot of these projects can be in a very early development stage and not have much data on which approaches they're going to take. They have many options available to them, and I'd say the earlier you consider tools like this for your analysis means the earlier you can start evaluating those options at a high level. And then later down the line, you can take that to another level of detail to help answer your more detailed questions as you start to make clarity, to put stakes in the ground. In a very open environment where you have lots of options available to you, it can be very hard to pinpoint one thing that's certain. But simulation can help you play through those what ifs early on. So yeah, I think even if you're in a low information environment, you don't have a lot of data, you don't have a lot of certainty. That's not to say that simulation and these approaches can't help.
Yeah, just to run different scenarios, isn't it? To see what is. No. Okay, thank you. Next question is around, I have responded to the chat, but perhaps add a little bit more. But there's a question, how does a port and its prospective expansion plans balance the ability to serve different sectors, e.g. serving offshore wind and defence? That's a very good question. In my experience, ports are very adaptive businesses, so they generally respond to the market. Some terminals will be entirely focused on their particular sector. So if you're looking at, say, a container terminal or something, it's much harder to adapt that to a different use. But in offshore wind, generally they're quite heavy capacity kind of industrial zones, so that I think there is opportunity then to serve allied or alternative markets. And defence is a good example. So if it's kind of supply side of defence, so logistics, supplies and things being put onto vessels, there's no doubt a port could be adapted for that from offshore wind relatively easily. There are kind of security and issues around that need to be solved. But when a port investment or a development is being considered, those alternative industries can be really critical. If you've got a weak business case, and particularly if you're looking at future offshore wind markets that are shifting or moving, if you end up with a year or so without operations, that can be really pretty disastrous on a kind of commercial mapping of an investment. So if you have the capacity to do alternative industries, that can certainly swing a business case into a positive space. Okay, next question. So
sorry, Stuart, can I just add to that?
Yeah.
Our simulation team has a strong capability in the defence sector, and we work with ports in that sector. I think I'd echo that. Yeah, quite often they are separate ports, but we're seeing more and more sort of connections between these. And a lot of our studies involve looking at the multiple reasons for traffic in and out of channels and into ports, and how those interact. And we can take assumptions about what that traffic will do in the future. If we think oil and gas traffic will go up and defence will go down, or given current news that defence traffic might go up, we can use those assumptions in the simulations.
Next question: how do you validate simulation models against real operational data?
Yeah, that's another good one. So I think, again, in an environment where some of these projects are new, there's not a lot of floating wind out there that's operating. We're taking assumptions and we're looking at how those build up into a future program, and using experience and those examples that are out there as our sort of base case, and understanding how a particular project might be faster or slower, or bigger or smaller, and how that might affect things. We have to rely somewhat on that expert judgment. But as with something like fixed bottom wind, there's more examples out there that we can validate against, and we can use those assumptions to drive our simulations. So yeah, there's multiple ways, but against historical data and with expert experience.
Yeah. The next question actually leads quite nicely, but the role of digital twins that's actually, I think, more around the kind of asset management side of things. I don't know who's best to pick that one up.
Praveen, do you want
to? I can start, and maybe Steve, you can add more. So I think when it comes to operations of some of these assets, I think what is likely to happen is, you would have a range of decisions to make, from everyday tactical decisions, which would need to be done immediately and probably on a shot, looking at the immediate future, but then starting to look a bit more wider, looking at the scheduling set of things, and then into the kind of the long term. They all need to go hand in hand. They are related. So this is where I think, while short-term decisions can be taken, and digital tools can actually help in all these different areas of decision making, but it's always, and this is where tools like simulations actually are critical for making some of these decisions, because simply heuristic based or very simple decisions just based on data alone actually has some limitations, and there's a need for the physics and the boundary and the underlying logistics to be taken into consideration before making decisions. And if you want reliable decisions, digital twins based on simulations are critical for those decisions. And maybe Steve, do you want to add some more?
Yeah, no, I think you hit the nail on the head, that the digital twins without simulation, without modeling, are quite often, they're mirrors to the real world. They're showing you what your current state is, and everyone would expect them to have that, but they don't allow you to take action without having some forward-looking predictive element. So I think simulation, we've long said that simulation is one of the most important components of that, and I only see that growing in the future. The other thing to say here is that AI comes into that with the ability of AI to automate some of this, to look at current trends from your digital mirror, your digital shadow, and then to trigger running of simulations to understand what might happen. A lot of this can be automated, and I see huge potential for that. The different technologies in the digital twin to come together and make a lot of this easier and faster and more value add. So yeah, I definitely see predictive simulation playing a big role in that.
Okay, thank you. I'm just going to pick two more questions. So one specific one about the study, Steve. So in the study you had slightly staggered project start dates.
Yeah.
2 or more projects were to start at the same similar time. Would this significantly change the viability and outcomes?
Yeah, I think it would. I think within the parameters that we used, there was some sort of flex and availability. So maybe it wouldn't cause the biggest issue. I think it's hard for me to say the precise answer to that, because without it is complex. It's a complex supply chain. There's multiple ports involved, multiple projects. Without putting those start dates into the model, I shouldn't guess at what that's gonna have, what impact it will have. I should probably use the model to do that. My guess is that yes, if all of these projects started at the same month and the same year, and they were all looking to complete within a compressed time frame, that there would be challenges doing 4 offshore wind projects from a small number of ports around Scotland. I think the bigger challenge is the UK government's got a plan to do many more projects than that. So actually the limitation should be explored, and the staggering and the start date should be explored more through modeling them and understanding what impact they'll have, rather than trying to guess at what the impact will be.
Okay. The question again, a fairly precise question from Tice, but how is weather modelled to ensure that different scenarios are affected in the same way, so that varying start dates of activities do not influence the overall output?
Sure. Really great question. So what we do with Witness is each scenario is run multiple times. So I think in this case we ran 50 replications of each of our 50 scenarios. In each of those replications, we are using the same random number streams. So the weather we are sampling and understanding what the weather will be like today in replication 1 of one scenario is the same as we're using in replication 1 of another scenario. So because we're doing that, we're able, and by doing enough replications as well, we're able to understand what the best and worst case outcomes were for a particular strategy. So we're able to replicate those. If I want to run replication 1 again and see and watch its animation, I can do that. It's completely replicable, and that's why these are called pseudo-random number streams. They're not truly random. We can replicate them, but we make sure that the scenarios are on an apples for apples basis. They're based on the same random numbers.
Yeah. Okay. Then one last question, just about data maturity. It's been asked a couple of times, but so as discussed earlier, so you need data for the more predictive simulation. For example, you need a depth or bathymetry. Does it need to be more accurate? So database through an MBS or an open source data, is that enough? Additionally, does this data need to be from a developer, or Haskoning will conduct the study to gather the data?
So just talking to the ASCO, the case study we did there, we were not looking at that level of detail. We were making an assumption, if we had chosen this port as capable of supporting a project, that we did not need the depth and bathymetry data in any level of detail. We knew that the vessels could access that port with the components that we were looking at. So we'd made an assumption. If you wanted to get into what does the bathymetry, what does the open source data or proprietary data mean for navigation, that's a lower level of simulation, which Haskoning also offers, but that's kind of not what we were doing within this study.
Yeah. Okay. Good. I think we will close here. We are a little bit early, but I'm just aware how long people want to listen to questions and answers. We will respond to the other questions, so we'll prepare written responses. I just want to say thanks to everyone for joining. Apologies to Tian again for not being able to join the call, despite preparing and getting ready. If there's anything you saw today that is of interest to you, if you want to talk about any of these topics or just explore thoughts around simulation and what it can do, it can solve a many different range of kind of problems and challenges, and we're very happy to talk that through. If there's something you'd like to pick up with us, with any of the team, so please get in touch. As we said earlier, the event will be available on our channels, so that'll be shared with you afterwards, should you want to hear any of us speaking again. Thanks everyone. Have a good afternoon and day and evening for those joining from Southeast Asia. So thank you and goodbye. Thank you.